Alright, you guys, I've found a question that asks us to find the standard deviation, but it's from 2021, but I thought may as well just do the entire question for now. So, starting with the first part, we know that the mean is 7 minutes and standard deviation is 1.5. Assuming that a normal, it's about coffee, I think, yeah. Assuming that a normal distribution can model, find the probability that a customer receives their coffee within 5 minutes. So start by sketching a curve. Also, it's interesting that they've literally asked you to do a working or a diagram. So if the mean right in the middle is 7 minutes, and we want the probability that the customer receives their coffee within 5 minutes, then looking at this. Now the word here is within 5 minutes, meaning you want it to be less than 5. Therefore, we're looking to the left of this value. Standard deviation is 1.5. So in our graphics calculator, you could actually write this as part of your working out. To find the NCD values, we're going to use normal. So the values we need to input are for lower, upper, mean, and SD. So in this situation, your lower limit would be a really large negative number. I think we could get away with negative 100 for this. You could use 1,000, 10,000, depending on what the range of numbers is like. Upper limit would be 5. Mean and standard deviation are as normal. So let's go and punch that in. Okay, never mind, I'll just go with negative 1,000. Then we just press. Great, so the probability of the customer receiving their coffee within 5 minutes is 0.09121. Gonna leave that as that. Great. Remember to write your sentence as well, though. Great. For the next question, one day the cafe has 150 customers who order takeaway coffee over the afternoon period. Okay, would you expect? So this is an expected value question, and whenever you see that, you got to find the probability of whatever they're asking for, and then multiply that by the value of customers or whatever the context is given. In this case, it was 150, which is n. Cool. How many of these would you expect to have to wait for between 8 and 10? Great, so that's nice and simple. Sketch your curve again to visualize. Mean right in the middle, 7, and then 8 and 10, which means you've got roughly that area there. So in this case, your lower limit would be 8 and upper limit would be 10. Mean and SD are the same. Okay, so it is 0.2297. You don't need to use the symbols. You can just use your words if you want. Let me just check that again. Alright, so the answer would be this probability multiplied by 150. If you didn't know how to use this calculator as a normal one, you just go to menu and select 1. So we've got 150 times 0.2297, which gives us 34.45, which is basically 34 people, roughly. Or because you had a little bit over 34, you could say both answers should be correct. Let's just take a quick look. Yep, 34 or 35 customers. Oh, okay, and that was a merit question. Nice. Easy, achieved, easy merit. Alright, this was the next question, which is asking us to find the standard deviation. It's the same as I've said before when finding mean. We need to use the formula x minus mu over standard deviation. It will be given to you on the graphics calculator, but we need a couple of things before we use the formula, mainly z-value. Okay, so manager noticed particular staff was rostered on 30% of customers. So area is probability as a decimal, so 0.3. Waited less than 5 minutes to receive their coffee. The mean time should make to deliver is still approximately 7 minutes. Okay. The manager suggests this means that blah blah blah. Okay. Facts about calculate an estimate. Great. And then we have to either agree or disagree. Okay. Now for inverse, there are a couple of things that we need. That is tail area, we already know. But for calculating z-score, we need to enter mean as 0 and standard deviation as 1. So if we sketch a curve, mean is still 7. Apparently the customers waited less than 5 minutes. So the tail would be left. Great. You could say as part of your working using graphics calculator. Let's go ahead and enter those so that we could get our Yep, so this is what I mean. Sometimes you could have a negative z value, and I just don't want you guys to ignore that. Z would be negative 0.85, is it? Oh, 0.5244. Don't ignore the negative. Okay. Right, so once we have that, we can just plug that into the formula. So this is now negative 0.5244, and x is 5 minutes, mean is 7, and standard deviation is what we don't know. Rearranging for SD is probably easier. All you're doing is swapping the values around. So standard deviation would be 5 minus 7, which is negative 2, over negative 0.5244. That is why it's important to not ignore the negative. So now both negatives gets cancelled and we are left with this. So the answer would be 3.81 minutes. We haven't really answered the question though. I mean, we've figured out what the standard deviation is, so that's good. They are also wanting us to discuss if we agree with the manager's suggestion or not. So we are comparing, because the mean is still the same, the new standard deviation. So originally the standard deviation was what again? 1.5. It's pretty much more than double now. So old standard deviation, can't spell, was 1.5 minutes, and now it is, well, for this particular staff member, it is 3.81 minutes. Okay, so larger standard deviation means more variation. As in, their times will be spread out more. So what did they want to do? They wanted to reward the staff member for good service. So if their standard deviation is larger, that means their times are going to be more spread out, which to me sounds a little bit like inconsistent. So even though the shortest time that customers are waiting is less than 5 minutes, the higher end could also be quite more varied, as in the longer waiting times will also be higher. So by evidence, no, we can't reward this person, unfortunately. Cool. So yeah, that's how you work out the standard deviation. Just remember to not ignore the negative. Carry that forward into the formula. All you're doing is swapping the standard deviation with the z-score, and the rest should work out.